If you can do parallelograms, you can do rectangles. Adding one little piece of information to rectangles, building on parallelograms. So a rectangle is a parallelogram with the addition of 4 right angles. So just like parallelograms, opposite sides are parallel and congruent, and the diagonals bisect each other. So because I have a parallelogram, because I have a right angle, we'll end up using the Pythagorean theorem. In fact, that's our hint for this problem right here. The door to the left is 8 feet tall, and it is 3 feet wide. And it wants to know how long is each diagonal. So that means from corner to corner, right? And it says each, so I'd be doing the other direction as well. Use the Pythagorean theorem. You can see when I split this door frame, I've got my right angle here. Remember, a squared plus b squared equals c squared, where c is always the hypotenuse. So a squared is 8 plus b squared is 3. Leg squared plus leg squared is hypotenuse squared. 64 plus 9 is c squared. 73 equals c squared. And then take the square root of both sides. And it says round to the nearest tenth. Square root of 73 gives me about 8.5 feet. All right. Now this is a question you've heard before. Is every square a rectangle? All right. Here's a square. Opposite sides are congruent. We know a square has 90-degree angles. So yes, a square is a rectangle, but the other direction, is a rectangle a square? No, because not all 4 sides are congruent. Is every square a rectangle? Yes. Is every rectangle a square? No. All 4 sides must be congruent, right? Okay, and the problem down here, we've got a stained glass window. It's reinforced with diagonal braces to keep it stable. And it says AB is 10 and CE, E is right here, this point. So let's see, back up. CE is 5.5. How long is BD? All right, so I want to know, let's highlight that so I can see that a little bit better. I want to know BD. What do we know about the diagonals of a parallelogram? Diagonals split each other in half, right? And then I also know in a rectangle, I didn't finish this problem up here. It said, how long is each diagonal? Well, it makes sense. If I were to do the Pythagorean theorem again, I would get the same measure for the second diagonal of 8.5 feet. So my diagonals are congruent. If this piece is 5.5, this piece is 5.5. So when I add that together, I get 11. So if the diagonal in one direction is 11, meaning this way, then the other diagonal is also 11, because the diagonals are congruent.